If you are using any version of STAAD, then probably you have noticed a new announcement in the news feed. STAAD.Pro CONNECT Edition Update 9 is now available. You can expand this post and check the key updates in the new version. Like a new mass model and notional load generator is included. American steel design code is also updated. Now, due to any change in the analysis and design engine, ongoing project results might be affected. So, it is very important to understand each and every change in the new version before upgrading. Hi, I am Surajit Ghosh, and in this video, I will discuss about all the important updates and enhancements of STAAD.Pro CONNECT Edition Update 9 and help you to decide whether you should upgrade your existing STAAD to this new version or skip this update. Before that, I just want to be clear that in the next 20 minutes, I will discuss about the new features and bug fixes only in the latest version, and updates in any prior build will not be covered. If you are using any older version of STAAD, like the early builds of CONNECT Edition or even the V8i version, then you need to go through the revision history file of previous builds to get a complete idea. There were several major updates in the last release of STAAD, which is update 8, like auto generation of wind load as per IS 875 Part 3 code, or implementation of Canadian Steel Design Code S16 2019. This will not be covered here. You can check my previous video on STAAD.Pro CONNECT Edition Update 8 to get more details. Whenever a new version of STAAD is released, this information is provided in the newsfeed and also in the connection client. I have already installed the latest version of STAAD, so it is not available here. But you can notice the update information related to other products. We can install the latest version directly from here. This requires admin rights. So you should check with your IT team before upgrading to the latest version. For more information about the update and installation, you can refer to my previous video. In update 9, there are more than 90 updates and I have grouped all this in different categories. I'll start with the major enhancements in the load generation module, cover the analysis, design and generic UI updates, and finally discuss the improvements in the interconnected modules like in RAM connection or RCDC mode. Only the major updates which are very important for the overall performance of the program as well as for the analysis and design results will be covered. For rest of the updates, you can check the revision history file. Link is provided in the video description. In last couple of years, there have been a lot of development effort to minimize the modeling time and to automate the load generation. In the last release of STAAD, a new feature was included to auto-generate the wind load on different types of structure as per IS 875 Part 3 and Chinese code. Now we can generate the wind definition easily and apply the wind load on building structure from different directions using the wind load generator option. In update 9, another option is provided in the load generation page, mass model generator. This option can auto-generate the seismic mass for any type of structure. Seismic analysis plays an important role for all type of structures, whether a concrete building or a steel PEB structure. We need to perform static or dynamic analysis to find out the effect of earthquake load and accordingly determine the section size or reinforcement. One of the challenge of seismic analysis is to generate the seismic weight or mass model. There are different methods available in STAAD to define the seismic weight. For static analysis, we can add the weight under seismic definition. One common approach is to copy the gravity loads from the dead load and live load case, paste it under seismic definition, and then change the syntax using input editor. This is really time consuming. Also, if we perform dynamic analysis, This seismic weight in the vertical direction is not sufficient. For dynamic analysis, we need to create a mass model with mass in all three orthogonal directions. We can define this mass model under the first primary load case, where the response spectra or time history load is added. Another approach is to create a mass reference load case and add all the seismic weight under this load case. We can add a mass model under a mass reference load case, and during static or dynamic analysis, seismic weight is calculated directly from this load case. This is the easiest approach as we don't have to define separate weight for static and dynamic analysis. For more details on seismic analysis and mass model, you can refer to my previous video on modeling for seismic analysis. Though we have already defined the gravity loads under different primary load case, still we cannot use those load data to generate the mass model, and only option is to manually copy paste these load items thrice to form the mass model, or use a custom macro which can generate the mass model. To eliminate this tedious process, in update 9, a new option is provided using which we can auto-generate the mass model. To use this feature, we need to first add the gravity loads under primary or reference load case with proper load type like dead, live, or snow load. Load type plays a vital role for mass model generator as this feature is linked with few specific load types, and the default load factor depends on the load type. I have already included all my gravity loads under dead and live load case. There is another dead load case with load type none. Though the seismic definition is created, I have not included any seismic weight under this as I want to perform dynamic analysis later. To generate the seismic mass model, we can simply click on this tab. This will open the mass model generator window. From here, we can generate the mass model either under a mass reference load case, or we can create it under the first dynamic load case. If there is no dynamic load case present in the model, then this option will not work. Next, we need to select the gravity load case which we want to consider for mass model generation. By default, all load types which are meant for lateral load like wind or seismic load are grayed out. If there is any load with load type none, we cannot use that for mass model. Program automatically includes the dead and live load with corresponding factor in the list. That's why load type plays a vital role for mass model generator. We can further change the load factor if required. For example, under clause 7.3 of IS 1893, code suggests to consider 25% of live load with load intensity less than 3. We can easily consider this and change the load factor for live load case. Note that only gravity loads in the global y direction are considered during mass model generation. Any other load component, load in local axis, moments are ignored in this process. Apart from that, there are few load types which are not considered. You can check the manual for more details. I will create a separate video on this. Once done, we can simply click on the Generate tab and see entire mass model with mass in 3 orthogonal directions are added under a mass reference load case. Easy, right? This feature will obviously minimize our manual effort by generating the entire seismic mass in just a click. Unfortunately, no option is provided here to select the direction, so we cannot use this to generate the seismic weight for static seismic analysis only in the y direction. We have to generate the mass model. Also, we cannot copy paste data in this table, which might have been a good addition to copy data directly from an existing Excel file. Another useful load generation feature is included in the autoload combination window. Previously, If we want to add a notional load for direct analysis or P-delta analysis, we have to do it manually for each load case, and there was no option available to consider that during load combination generation. Now, in the auto load combination window, an additional option is provided for repeat load case to include the notional load from different directions. We can specify the load factor and direction of the notional load in two orthogonal directions. This will create additional repeat load case with notional load from different directions. See, four separate loads are created, one for each direction with correct load factor. Using this, we can include the notional loads easily without any manual effort. This floor count option is provided for Chinese code, where the load factor is determined from clause 5.2 using this equation. For any other design code, we need to manually provide the load factors. Final update related to the load generation is the projected load option under the plate pressure load. In previous version of STAAD, we can apply plate pressure load either in the global direction or in the local axis of the plate. If a plate is inclined to any global plane, like an inclined roof of a warehouse, and if we want to apply a load in the projected direction, then there was no option available to handle this. We need to calculate the intensity manually and apply that load in the respective direction. Now, we can define the actual load intensity and select the projected load direction. Program internally calculates the projected load intensity value depending on the slope of the plate and apply the load on the projected area. This option is very useful to apply load on overhead water tank structure. Note that this option is available only for full plate pressure load. That's all from the load generation updates. Next is the enhancements related to the PEB industry. If you are using STAAD to design a PEB structure, then this might be helpful for you. We have noticed few crash issues when tapered sections are designed using IS 800 2007 and Canadian code. For Indian design code, there was a specific crash issue when wave stiffeners are defined using TSP parameter and for a particular range of wave thickness. This crash issue has been fixed now. Also, we have noticed that in update 8, if the bottom flange width and thickness of the tapered or user table wide flange section is specified as 0, then program crash during member design using Indian or Canadian code. This problem has also been fixed. So if you use update 9 to design tapered member or user defined section as per IS 800 2007 or CSA S16 code, you will no longer experience any crash. For AISC 36016 code with seismic design, an internal check is now included to validate the seismic check results and print correct results in the output. Next, I will discuss the updates related to the analysis and design engine, and there are few major updates related to AISC 360 code. Two additional parameters are now included for AISC 36016 code to perform slenderness check for tension member. As you know, for tension member design, effective length factor KYKZ is considered as 1 and member length or LYLZ value is considered for slenderness calculation. So, if we specify LYLZ along with KYKZ, then KL by R value is considered for compression slenderness and L by R is considered for tension case. If we want to specify separate length or factor only for tension slenderness, it was not possible. To handle this requirement, an additional parameter TSL is now included only for AISC 36016 code, using which we can specify the slenderness length for tension member. By default, it is considered as the length of the member. And second parameter, SRT, defines how this value is used during design. By default, slenderness ratio for tension load is calculated considering the TSL value, but if SRT is specified as 1, then as per clause D1 and commentary of AISC 36016 code, the maximum length among Ly, Lz and TSL is considered for slenderness calculation. So, if we want to consider different member length for tension slenderness check, we need to specify TSL value with str0. If we want to compare the effective length with tension slenderness length and consider the maximum length, then we need to specify value as 1. Note that there is no change in compression slenderness calculation and it is still calculated using KL by R value. Also, there is a fix related to the slenderness check report for tension member. In previous version of STAAD, though tension slenderness ratio is critical, still ratio for compression load is reported in the output, which is now corrected. There is another major fix related to the slender T-section design using AISC 36016 code. Previously, for slender T-section, effective width reduction factor C1 was incorrectly considered as 0.18, which is actually for HSS section. It is now corrected and C1 for slender T-section is considered as 0.22. This will affect the compression capacity and overall design results. And if a slender T-section is designed in your model, you can notice a ratio mismatch. Finally, there is a fix related to the torsion design. In previous STAAD version, we have noticed a crash when torsion design is performed for a member which fails during strain check. For such a member, though torsion check is irrelevant, still program tries to perform torsion design and that causes a crash. Now this issue has been fixed. For IS 800 2007 code, there is one update related to the T-section optimization. If a T-section is specified from a wide flange database, CG of the section was incorrectly considered during section selection, which is now fixed, and correct CG is now considered. That's all from the analysis and design updates. There are few updates related to the New Zealand and Canadian code, which is not that important. Next, I want to discuss the updates in the post-processing mode. There are a couple of updates related to the steel utilization ratio table. As you know, for AISC 36016 code, critical ratio from different design parameter blocks are reported in the post-processing table, and we can check and filter these values. Additional option is now provided to sort these results according to the allowable ratio value. Previously, we can sort the results only as per the member number. Apart from that, we can now select the member number or groups from the results setup page, and results for those selected members are only displayed in the utilization table. There are also few updates related to the results along a line and cut line feature. You can check the details of this and other minor updates from the revision history file. Moving to the updates in the physical modeler. Have you ever used this module to create any model? Physical modeler has several advantages over the analytical modeling approach. In my upcoming series on PEB structure, I will discuss how we can use this physical modeler to quickly model a tapered profile and assign design parameters like DJ or KYKZ to a physical member. In update 9, there are two major enhancements in this module. First one is the inclusion of member truss specification. Under axial behavior, member truss specification is now included, using which we can specify a member as truss. Second one is the cable member specification. From here, we can declare a member as a cable member by specifying the initial tension value and location or unstressed length. We can further perform advanced cable analysis for these members. For tank module, there is one minor update. When a tank model is generated using the structure wizard, all the walls are now marked properly in the analytical model. Previously, a generic name was used to denote the walls, but now all these walls are properly described so that it can be identified easily in the analytical modeler. Along with that, in update 9, several crash issues have been fixed and overall performance of this module is now enhanced. And this is not only for the physical modeler. Rather, the overall performance of STAAD has been enhanced. Several crash issues have been identified and fixed, including a crash during file closure which was present in update 8. Also, STAAD is now certified in Windows 11. If you are using Windows 11 operating system, then you can install update 9 without any problem. There is no update or enhancement related to OpenSTAAD. No new function is added to the library, and there is also no enhancement related to the OpenSTAAD manual. But there are few new verification examples related to IS 875 Part 3, WinLoad application, and Canadian steel design code. If you want to know how STAAD calculates the WinLoad based on IS 875 code, you can check the verification model and detailed calculation from the help manual. There are several small updates, like the Chinese steel design workflow has been updated to handle models which include P-delta analysis and user table general sections. Finally, I want to discuss about the interoperability and updates in the integrated modules. There are several updates in the ISM module. Analytical Modeler can now import release information from an ISM file. Loads in the local axis and uniformly distributed loads are now correctly recognized. By the way, ISM functionality between analytical and physical modeler is not same. There are several differences, like physical modeler can read plate and load data from an ISM file, which is not possible in the analytical modeler. Along with this updated STAAD, latest version of Advanced Concrete Design module, RAM connection, and STAAD Foundation modules are provided, and you can check the build numbers from here. If you use any of these modules in your project, then you can notice several new features, like in RAM connection, new gusset connection module for AISC, Australian and New Zealand code, and metered knee and hollow section connection for American, Canadian, and Euro code is implemented. RCDC module now supports ACI 318 2019 code for member design. German National Annex for Euro code is also available. If you update your STAAD version to the latest, all these modules will be automatically updated to the latest version. No additional installation is required. Now, the final question, should we upgrade to this version? Well, there are lots of enhancements related to American, Canadian, and Indian code. So, if you use any of these codes for member design, then you should upgrade to this version. Also, the new load generation features are very useful and can save lot of time. Finally, several crash issues have been fixed, which no doubt improve the overall performance of the product. If you use any STAAD version before update 8, then I'll recommend to update to this version. If you are using update 8 with any other design code like Euro code and not concerned about the load generation features or overall performance, then you can continue with that. What do you think about this new version? Do you think this mass model or notional load generator feature will help in your project? Let me know in the comments. Thanks for watching.